So the last thing for 9.2 that we have to talk about are the cofunction identities. The cofunction identities are a result of a few different things. One, if we would apply the sum or difference formulas, because of the fact that pi over 2 is 90 degrees and the cosine of 90 degrees is 0 and the sine of 90 degrees is 1, the formulas work out in such a way that those things are cofunctions. Now, this is where the name of the functions come from. Sine and cosine are cofunctions, hence why one's called the sine and one's called the cosine. The graphs are going to look the same. If we flip it across the y-axis, that's what this negative on the theta does, and we add on a pi over 2, what that's going to do is it's going to result in the original function. You really only need the top 3, so make yourself a little note that the top 3. These are not formulas that you are going to have memorized. They are formulas that I will write up on the board, but they are formulas that you're going to need. So please write those down, and then we will talk about how to use those formulas. I guess in a way, you would probably just need the sine, actually the secant, and the tangent. You would want to know those 3 because these 2 are cofunctions. These 2 are cofunctions, and these 2 are cofunctions. So if you want to make yourself a little note that these 2 go together, these 2 go together, and these 2 go together. So our cofunctions are just that. Sine and cosine are cofunctions. They are always a pi over 2 minus theta apart. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. So as long as you know that those go together, and it is exactly from the name, and it's based upon how their graph looks, and what we know about transformations. This transformation would flip it over the y-axis, and I believe it would move it to the right of pi over 2. So you could transfer any of our functions into its cofunction by doing that very thing. So hopefully you have those written down. I would maybe take a screenshot of those. That's a good one to have in your camera roll so that you can have access to those things. But if you forget those, you can always apply the formulas that are already on the board, those sum and difference formulas. You just put pi over 2 for the alpha, and theta is theta, and that would be the beta in the formula, and then it would work out actually for you anyway. So example 7 says to write tangent of pi over 9 in terms of its cofunction. Well, if it has a co on it already, you take it off. If it doesn't have a co on it, you put it on. And so the tangent of pi over 9 uses the tangent of theta formula. And the cotangent will be the cofunction. Makes sense, right? And that's pi over 2 minus theta. So wherever we see the theta, just put a pi over 9. And so that would be the same as the cotangent of pi over 2 minus pi over 9. Now, how could we actually make that look a little nicer? Well, if we changed those with our rules of fractions into an 18 denominator, this would be 9 pi over 18 minus 2 pi over 18 is the same as 7 pi over 18. So if you were to put into your calculator in radian measure the tangent of pi over 9, or if you took the tangent of 7 pi over 18 and then just flipped it, you would get the exact same value. So that is how the cofunctions work. So you'll notice that 14 through 17 down here use our cofunctions. What they want you to recognize is they are showing that pi over 2 minus theta model. And so all you got to do is take off the original function, put on its cofunction, and I'll show you what I mean. So this is the same as the secant of t. This is the same as the cosecant of theta. This is the same as the tangent of x. This is the same as the cotangent of x. Now, if you don't believe me, let me show you one of them, okay? Let's do 17 for a minute, and I'll show you why it works like that, okay? So if we were to do the tangent formula, that's up on the board. So let's break down why these happened like this, why they become the cofunction. If we look at 17 a little closer, if we apply the formula up on the board, the tangent of pi over 2 minus x, that's a better way to show you anyway. That would be the sine of pi over 2 minus x over the cosine of pi over 2 minus x. I think I picked the weirdest one to flip. The top is the cosine of, I'm sorry, let's do the actual formulas. I was going to use the cofunction formula, but that defeats the purpose. Okay, if we do the sine difference formula up on the board, we get the sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. So I just used that formula, and every place that I saw alpha, I put a pi over 2, and every place I saw beta, I put an x. And then I'm going to apply the cosine difference formula, which is the cosine of alpha times the cosine of beta plus the sine of alpha times the sine of beta. Now, you're not going to have to do this because the formula takes care of it for you. But let's analyze pi over 2. On the unit circle, the point at pi over 2 is 0, 1. So the sine is 1 and the cosine is 0. So this is 1 and this is 0. So let's put in those 1s and 0s and watch what happens. We get 1 times the cosine, which is a cosine. We get 0 times sine, which is 0. And here we get 0 plus the sine, which is cosine over sine, which we learned is the cotangent. So because of the unit circle, because of the transformation, because of how those things work, the tangent of pi over 2 minus x becomes a cotangent. They are cofunctions. Anytime you see in the parentheses pi over 2 minus whatever, it will always become the cofunction of that whatever. And so you don't have to do this. I'm just kind of proving to you why it did work out the way that it worked out. Okay, so so that's kind of how the cofunctions work. Again, those functions I don't use too often, and occasionally, because technically if you see that and you see a subtraction, you can apply the formulas up on the board and you can, it will work its way out. Yes. So remember, on the unit circle, pi over 2 is 90. No, just use the point related to pi over 2. And that's why it works out this way. Pi over 2 all the signs become ones and all the cosines become zeros, and then it ends up simplifying really, really nice. So.
Can you zoom back in on the bottom of the problem? Where did the sign of x go on top?
It was multiplied by 0. 0 times the sine of x. The cosine of pi over 2 is 0. So that's 0 times the sine of x, which becomes 0. Okay. Okay. So now, so that was kind of like just a proof of how that works. So now we're going to do a few of the homework problems together just to make sure we're on the right page. Okay. So the homework is right below it here. So if you could at this time, we're going to do some of these right now. Okay. So if you could open the 9-2 homework up and let's talk about it. So for problems 1, 2, 3, and 4, if it is in degree mode, what you're looking for is any two things when either added or subtracted, which will give us this value using our unit circle values. Now, lots of things on our unit circle are 15 degrees apart. 60 and 45, they're 15 degrees apart. 45 and 30, they're 15 degrees apart. 120 and 135, they're 15 degrees apart. There's tons of things on our unit circle that are 15 degrees apart. If you can use the first quadrant, that's my suggestion, to use the first quadrant because they're nicer in our memory banks than some of the other quadrants. So when I see this, I need a negative, so I need the bigger one to come second. I'm going to think about this first using unit circle values. I'm going to think about this as 45 minus 60. Now you could have also done 30 minus 45. Any two things on the unit circle that have a subtraction or an answer when you subtract them of negative 15. Okay. Would you agree that 45 minus 60 is negative 15? Okay. So that's your first step. What are two things that make that value? Okay. Now that you've found those things, we're going to utilize the formulas that are up on the board. Okay. So the formula is the cosine of alpha minus beta is the cosine of alpha times the cosine of beta plus the sine of alpha times the sine of beta. So that's just the formula that's up on the board. The formula up on the board I've kind of color-coded. So if it's a plus in the middle, you use the kind of bluish color. If it's a minus in the middle, use the yellow. So it's kind of color-coded as to which one to use. So that's the minus one. So I used the signs up there that are in yellow. And I'm going to place into our formula, every place I see alpha, I'm going to put a 45. Every place I see beta, I'm going to put a 60. Okay. So that's going to be the cosine of 45 times the cosine of 60 plus the sine of 45 times the sine of 60. Now it says exact value right here. Exact value means you have to use the values on our unit circle. Now 45 is that square root of 2 over 2, square root of 2 over 2 point on our unit circle. So both of the 45s are square root of 2 over 2's. Okay. The 60, remember 60 on our unit circle is the 0.1/2 square root of 3 over 2. So the sine value is the y value, square root of 3 over 2. The cosine value is our x value, 1/2. And then following order of operations, following rules of algebra, don't make up your own algebra, we're going to get square root of 2 over 4 plus square root of 6 over 4. And then combine your fraction If they don't have common denominators, make them have common denominators. If they do have common denominators, which is pretty often, just put them over one denominator. We can't add a square root of 2 and a square root of 6. We can multiply them. We can't add them. They're not like terms. So that is your final answer for number 1. Are there any questions about how I got number 1? Yes.
Would we do the same thing for number 2, but instead make it 60 minus 45? Or like, instead make it tangent 60 minus 45?
So it has to come up with an answer of the negative 15. That's why the 45 comes first and the 60 comes second. You could have done 30 minus 45. That's negative 15. Any two things that make negative 15. So you could do 30 minus 45. You could do 45 minus 60. You could do, if you go over into the second quadrant, you could do...
so for number 2, which is...
Oh, wait. Oh, I'm sorry. I didn't know you were looking at number 2. So what were you thinking of for number 2?
Just 60 minus 45.
Yes, you can do that. So again, for number 2, yes, look for any two things that subtract to give you 15. Okay. Now I'm going to focus on the odd ones here. So I'm going to now do number 3 with you. Now, number 3 with you, I would suggest, if you know what negative 7 pi over 12 is in your head with radians, I am very proud of you. But even I look at that and go, I know that pi over 12 is 15. I got 7 15s, however you want to do it. But I would change that into degrees first. So I would make that the cosine of negative 105. And then I would find two things that when they add or subtract give you negative 105. Yeah, that would work. Okay, so one suggestion, which is a good one. Any two things you can figure out. So if you do 2, let's see. Yeah, that wasn't going to work. Okay, let's see here. Yeah. I'm thinking. So,
what about 105 minus 210?
105 is not a unit circle value. Yeah, that's what so what's 2? I'm getting there. I'm thinking. What'd you get? What'd you figure out? So 110 is not a unit circle value. Yes. Remember our conversion from degrees into radians or vice versa. Just do 7 times 180 divided by 12. 7 times 180 divided by 12 is how I got that. Got to remember that. Pi's are 180, so that's how I did that conversion. Okay, so I'm thinking. So let's go. Oh, here we go. 105, or I'm sorry, 135 minus 240. Aren't those both measures on our unit circle? Oh, there's tons. There's more than one answer. Let's just stick with the answer I figured out. So there, you just need to find two things that make the number you see there. Now you can use any of our unit circle values. 135 minus 240 is 105. So 135 minus 240 is technically negative 105. So you just start finding values on your unit circle that add or subtract that amount. Okay. Now that we've found that, took us a little bit there. Once we found that, this is going to be our alpha. This is going to be our beta. We are going to use the same formula we used with number 1. We did end up being a cosine minus a difference formula. So let's plop those in. So it's going to be the cosine of 135 times the cosine of 240 plus the sine of 135 times the sine of 240. Okay. Now this one has forced us to get out of our first quadrant, unfortunately. And so instead we have to use things in our first and in our second and third quadrant. Okay, so let's do 135. 135 is right here. It's the 45 in our second quadrant. That, yeah, negative square root of 2 over 2, positive square root of 2 over 2.
I just found the unit circle I have in my photos.
Yeah. So now, where we see the cosine, that is going to be negative square root of 2 over 2. And the sine is going to be positive square root of 2 over 2. So I'm just going to plop those in so we got them. Okay. Now let's look at 240. 240 is down here. That is the 60 in our third quadrant. So both x and y are negative. That would be negative 1/2 negative square root of 3 over 2. So the cosine is the x value. The sine is the y value. So that is the answers that we see. And then I'm running out of room, but I think we can fit it in there. Two negatives make a positive. That's square root of 2 over 4. A positive and negative make a negative. That's square root of 6 over 4. So our answer is square root of 2 minus square root of 6 over 4. Again, those aren't the only two things that have a difference of 105. If you found two others that worked for you, go for it. That's just after some trial and error. You know, that's where looking at your unit circle. 105 is a combination of 60 and 45. 60 plus 45 is 105. So if you can kind of do a jump of 60 and a jump of 45, that if I was looking at it, that's what I would have done in my brain. Okay, so that is how you do 1 and 3. Now I would like to jump to 5. Let's do 5 together. 5, 6, 7, and 8. We are actually undoing the formula. We're going backwards, okay? So we got to find the formula that goes sine, cosine, plus cosine, sine. So if you look up on the board, which one goes sine, cosine, plus cosine, sine? Well, that's our sine sum formula. So this is the same as the sine of alpha plus beta, because it's the sine of alpha cosine of beta plus the cosine of alpha times the sine of beta. That's how we know, because it's going in the correct order. Sine, cosine, plus cosine, sine. So if we look at this, the alpha is 20. The beta is 10. So let's put them right here and here, okay? So this is the same as the sine of 20 plus 30, or 20 plus 10, which is 30. Now, we know what the sine of 30 is by putting it back together. I didn't know what 20 and 10 was, but 20 and 10 add up to 30. And so I do know what the sine of 30 is. The height of the point at 30 is 1/2, and that's exactly what that value is. So that value, you're going backwards. Same thing for 7. They want you to undo the correct formula. So first off, of the 3 sets of formulas you see up on the board, the sine goes sine, cosine, cosine, sine. The cosine goes cosine, cosine, sine, sine. The tangent has that funky fraction. Which formula set does number 7 match up with? The sine, the cosine, or the tangent? The cosine. Now, if we go backwards, This formula has a minus. Does the cosine formula have a minus or a plus when we go backwards? It has the opposite of what we see there. It's a plus. And so this would be our alpha. This would be our beta. When we go backwards, this thing in a cosine formula becomes a plus. It's the only one, if you're looking at the main portion of the formula, that does the opposite. So this is the same as the cosine of alpha plus beta. So that's the cosine of 70 plus 20. And if you get a unit circle value, when you put it back together, you're not done until you find the actual unit circle value. So the cosine of 90, if you look at the point at 90, that's the 0.01. The cosine is our x value. The answer is 0. Any questions about that first section of the homework? I did the odds. The evens are going to follow suit and be very similar to what you saw there. Everybody good with 1 through 7? Okie dokie. Now I would like to do, what I would like to do is I would like to do, this is a proof, the identities that we had done, where you hold one side and you manipulate the other side until they match. I'm going to do 49 for you, but let's discuss 48, or 47, I'm sorry. If we look at 47, keep this side as your answer. Use the formula that's up on the board to manipulate that side. Keep in mind, my little hint to you is that the tangent of pi over 4 is square root of 2 over 2 divided by square root of 2 over 2, or 1. And so if you use the correct formula that's on the board, if you apply that formula to the sum you see here, keeping in mind that the tangent of pi over 4 is 1, you'll get the proof, the identity that you wanted. What I would like to do with you now is problem number 49. I'm going to hold this as my answer. So that's what I'm shooting for. And I'm going to manipulate the left side. Okay. The reason I think that I have something to work with on the left side is the cosine of a plus b, or the cosine of alpha plus beta, is a formula. So I know I have something to work with. So using the formula up on the board, I am allowed to replace this with the formula. So let's do that. So that would be the cosine of A times the cosine of B minus the sine of A times the sine of B, all over the cosine of A times the cosine of B. Now, using your rules of fractions, I know you guys love fractions, see how this right side is split apart into two pieces. So let's use our rules of fractions to split this fraction up. We're going to put this denominator under both pieces. So you're allowed to split it into two pieces. I want two pieces. I have two pieces. I have a minus. I have a minus. I have lots of things that are going to happen if I do that. So the fractions become the cosine of A times the cosine of B over the cosine of A times the cosine of B, minus the sine of A times the sine of B over the cosine of A times the cosine of B. Now keep glancing back at our answer for a moment. What is anything divided by itself? 1. So that's the one we were searching for. So that's 1. Now, if we evaluate these things separately, we can rewrite that portion next to each other or together. And we can write this portion together. Now, why did I want to do that? Can anybody tell me what? Yes, look at what we got up here. We have a multiplication of two things. we have the multiplication of two tangents. So if we write them as a separated fraction, you're allowed to do that. To multiply fractions, you multiply tops with tops and bottoms with bottoms. So by splitting the pieces up a little bit, it looks more like what we're wanting. And our final answer is 1 minus the tangent of A times the tangent of B. And so we got it. So that's kind of what you have to do for 47. Again, for 47, apply the formula up on the board to this side. It will lead you very quickly to the other side. Okay. And then 11 and 12 are, again, just verifying an identity similar to what we did on the 9-1. Okay. So I'm going to do 11 for you. For 12, my suggestion would be keep this as your answer, apply the formula for the left side. Okay, so let's do number 11. I'm going to apply the sum formula that's up on the board. This is my alpha, this is my beta. I'm going to use the sine sum formula. So that would be the sine of 360 times the cosine of theta plus the cosine of 360 times the sine of theta. Now what we're going to do is we're going to think about 360 on our unit circle. That is the point 1, 0. So now you're going to have to show what you're replacing. Cosine is 0. Sine is not 0. Wait. The sine is 0, yeah. The cosine is 1, which is 0 plus the sine. Or a final answer is the sine.